All right, welcome everyone. In this video, we are going to continue our work with the SF package and how we can define different geometric objects. We've talked about a point in the previous video. In this one, I want to talk about how we can define a polygon. And so a polygon object we define by setting up a sequence of points that form an outer ring, and maybe we can also add some additional holes inside. So we want to define our sequence of points as a matrix that has two columns. The first column gives me the x coordinate of each point. The second column gives me the y coordinate of each point. And each row is corresponding to a different point on the polygon. And these are going to be closed polygons. So that's why here we're looking at an example on the screen where the first point is at 0, 0, and the last point in this matrix is 0, 0. So this is going to close that ring off. And what that polygon would look like if we actually drew it, it's going to be, we would start at the point 0, 0 for this first row of the matrix. Then we would move to the point which is at 10, 0. So I'm not drawing this to scale, but we would go over 10 units to the right. Then we wind up at the point at 3, or excuse me, point 3, which has coordinates 10, 10. So now we go up 10 units. Then we go ahead and travel to point 4, which is located at 0, 10. So the x coordinate is 0, the y coordinate is 10. And then we wind up back at the point we started at, which had coordinates 0, 0. And then we connect these points in order. So we start at point 1, we go to point 2, then we go to point 3. These should be straight lines. Then we go to point 4, and then we go back to where we started with. And this is an example of a square polygon. We have 4 vertices, and we connect the edges in this sequence. So the ordering matters here. So what we're going to do is store the points, as in the previous case when we had just one point, we stored it as a vector, and then we entered that into the st_point function to create a geometric point. In this case, we're going to store multiple points in a matrix that has this structure, and then we're going to create a polygon using the st_polygon function that we apply to the matrix. And so we can define this matrix in different ways. The way that I have defined it over here is I entered my matrix. So I entered, there's 10 values altogether in this matrix. So I've actually entered all of these values first as a vector. This argument in the matrix function sets the columns, the number of columns. So it's going to help us arrange the values in this vector into a matrix. So this is saying we have 2 columns over here, and then there's an argument that is by row equals true, and this means it's going to arrange these 10 values into a matrix with 2 columns by assigning things to rows. So it takes these first 2 values. I've hit my last column. I only have 2 columns. So that's the first row. Then it moves over 10, 0. Those are the next 2 values, which make row 2, then row 3, then row 4, then row 5. So I'm going to clear this off, but what this code cell has, again, this first code cell on screen, is this matrix that I've drawn out. So this is a 5x2 matrix. We have 5 rows and 2 columns. But I will clear all this out, and let's run this code cell. And you can see we got exactly that matrix that we had drawn out earlier. Okay, so in this second code cell, we have very similar code as above. We actually entered the same exact vector inside the matrix function. We still have 2 columns, but I just want to illustrate what this by row argument is doing. If I set by row equal to false as opposed to true, then it's going to arrange the values by column. So we have two columns here. So it's going to determine you've got 10 values in your vector that you want to arrange into two columns. So each column is going to have 5 values. It arranges things by the column. So it's going to take the first 5 values and set up the first column. It would take the second 5 values and set up the second column, as opposed to the previous case where we took the first 2 values and that was row 1. The second 2 values was row 2. We're now arranging them by column. So we first figure out column 1, then we figure out column 2. Compared to the first one again, which was first figure out row 1, then figure out row 2, then row 3, and so on. And so by arranging them differently, we actually get a different matrix, right? This first row has the point 0, 10 as opposed to 0, 0. And the second row has 0, 0. So we could conceivably get a different polygon here. We could get the same polygon. In this case, we wouldn't even get a polygon because this is not a closed ring. The start point is at 0, 10. The last point in this matrix is at 10, 0. So we actually wouldn't get a closed polygon here. But we can run this code cell and take a look and verify that we get the same output that I was expecting. And this lines up with what we expected. So I'm going to clear these out since we're done with those. So that was the outer ring. We're going to define the outer ring using this first matrix up here, which was a closed ring, as opposed to this second way that we did it. So this matrix over here, we're eventually going to define an outer ring using this matrix. And these two matrices down here are similarly giving closed polygons that are going to make up holes on the inside. And in the code cell below, I've got 2 additional matrices that I've boxed in what each of the rows would look like in that matrix. So those are matrices with 2 columns. The first column gives the x coordinate. The second column gives the y coordinate. So over here, for that first matrix, we go from point 1, then we go up to point 2, then to point 3, then to point 4, and then back to point 1. So this is what we would call a hole. It's a closed polygon on the inside of the outer ring. And then we have a second hole, which is inside the outer ring that I've drawn over here. So this one starts at 5, 5, goes to 5, 6, goes to 6, 6, goes to 7, 5, and then back to 5, 5. So these are going to be 2 matrices that we use to define 2 holes that we'll have on the inside. I'll run these 2 these cells, and you can see the matrices that resulted from that we just plotted above. So now we're ready to combine all of these elements. So I'm going to take that first matrix that formed the outer ring and assign that to an object I call outer. I could call that whatever I like. I'm going to take this second matrix that we sketched out above. I'm going to call that hole 1. I'm going to take the other third matrix and assign that to hole 2. And now how I set up this polygon that has 3 different components, an outer ring and 2 holes, is I create a list out of all of the rings that I want in my polygon. So I've got an outer ring and 2 holes. So I create a list with all 3 of these matrices. So this is a list where each element in the list is a matrix. So now I've got a list of 3 matrices. I assign that to an object. In this case, I've called that object points, PTS, since these are the points that are going to make my polygon, but you can call that whatever you like. And now, once I've got my list of 3 matrices that are describing each of the polygons, Then we input the points that list into an st underscore polygon function, and that's going to create a polygon from these three separate matrices. So in this case, I'm going to create this polygon that I call PL1, and I have it enclosed in a set of parentheses, which means we're going to create this object PL1 and then display that object on the screen. So you can see the polygon, what it looks like. It's a list of three matrices, though it's not even necessarily clear that these are matrices. But you can see by the way it's being printed to the screen, it has a pair of coordinates without a comma between them. So that's indicating the first point. We have a space between the two coordinates. And then the comma here is being used to give us the next row of the matrix. So that's our polygon. And then we can plot it just using the plot function. We can plot our new object, our new geometric object, PL1. And we can see what that looks like down below. That looks like the object that we drew further up above. Okay. So we'll stop here, and in the next video, there'll be a question to practice this concept before we move on and talk about other geometric objects. Okay, thanks everyone.